In this video, we're going to go over actually pulling data periodically from Strava. This video is going to be more theory than actual code, since the code is actually fairly simple and we've already seen most of it in the previous video in our shell. To that end, we're going to run our periodic tasks using celery, and in a previous video I've gone over how to set up celery, and you can see that in the show notes. This video assumes you have celery up and running currently. With that, we're going to open up our activity/tasks file and go ahead and get started. I've gone ahead and imported a few things just to make things easier. We're going to create our first function of get Strava activities by user. We're going to pass in a user ID and days equals none. In this case, we're going to use function-based tasks with celery because this is a simple enough task that we don't need to really worry about including a lot of different things. The reason we're passing in a user ID instead of a user object is because we want to make sure we have the latest state of each task. When you create a celery task, it's going to run everything in an independent manner without any connection to anything else. You can save an object into your queue and pull that out later. However, it could have stale data and you really want to try to have the latest data. So to do that, we use the user ID so that we can reference that in our code. So we're going to do a user equals user.objects get, and then we're going to do ID equals user ID. And now that we have our user object, we know we need to do something with our social information. We're going to get all social connections based on this user for Strava. Generally, this is going to be limited to one, so we're going to get a query set back that should only have one object in it. However, if there are no objects in our query set, then we're just going to return none, because that means we can't actually do anything with Strava, so we just need to return and not even worry about trying to execute any of the rest of our code. From there, we're actually ready to get our Strava client, and we're just going to go ahead and use our mixin and pass it in our user object so we get a properly populated client. Much like in the last episode with our shell, we're going to create an activity iterator and call client.getActivities. It's going to set up our iterator to be able to loop through and do everything. We're going to set our acts list because we might want to do later processing, and this is just a good idea to go ahead and add it. Now we're going to actually loop through all of our activities in our activity iterator, and we're going to call getterCreate on our activity object that we created. The reason we're going to call getterCreate is because we had a decision to make. When we pull the data, do we create a new object for every activity that we have, or do we just merge it into existing activity objects? In our case, it's a good idea to go ahead and only create new objects for new data and add it to any data that's there existing. So with that, we're going to do activity.objects.getterCreate. We're going to set our external ID to the activity ID, and this is actually the most appropriate way to do our query. But just to be safe, we're going to do our source of Strava, because on some random unknown reason, we might have an external ID of the same ID with a different source. And then finally, we're going to set our user, just so that we have three independent pieces of information to make sure we get a truly unique object. And then from there, we're going to use our update with Strava function, passing in our activity object. And really, that's it. I mean, that's the sake of our method. I mean, this really would get us where we need to be without any more code. However, we need to be a little more intelligent about what we do. And one of the things we need to do is we need to actually go ahead and allow a date range to take place so that we're not calling the API more than we need to and overburdening the system and using our API requests up. Plus, it helps this process faster for each of our users, because if you think about it, you might have a user with 2,000 activities and you don't want to pull that down every day, because in all likelihood, at most, people are going to have 1, 2, or 3 activities, and if they have 3 activities in one day, man, they're really getting after it. But pulling down 3 activities a day is not going to take very long at all. So in order to do that, we're going to check if there's days, because by default we have days set to none. If there are days, then we're going to set our end and start date, and then we're going to modify our activity iterator to use their before and after query string arguments. In this case, we do a before this date and an after this date to get our range. It's a little bit different than what we're used to in Django, but once you realize what it's doing, it works out. And then finally, if there is no days, then we're going to use our normal activity iterator. So with that, we can now pull in our data for our user using a date range instead of just pulling down everything, and it still does the exact same thing. The final part to this piece of code is we're going to wrap our usage of our activity iterator in a try-catch block. And we're going to catch the exception of an HTTP error. The reason we're going to do that is because we could try to get our data and it throws an unauthorized exception. Generally, when you get this, it's because somebody has deactivated the use of our application on the Strava side, and we need to go ahead and handle that to not crap out on the execution, but let's go ahead and delete that social object because apparently they no longer want to use it. This will prevent us from actually executing it in the future, saving us API requests and saving us processing. So in that case, we're just going to do a social.get.delete. It's recommended that you go ahead and inspect the actual error to make sure that you verify what the error is and delete based on what that is. In this case, we're keeping it simple for the sake of this video. So with that, our get Strava activities by user is done. We're passing it in a user ID. We're getting the specific information for our connection with a social. We're saying, hey, if they don't even have a connection, then we're just not going to bother. If there is a date range set, then we're going to set our activity as iterator based on that date range. And then we're getting our activity and creating new objects if they need to be created, or updating existing ones. However, if someone has disassociated their account on the Strava side and not our side, then we're going to go ahead and delete their social object connected to that user so that we don't have to worry about executing that code for that user anymore. So it's all fine and dandy that we're able to get activities based on our users, except we don't want to set up a periodic task for every single individual user. So for that, we're going to create a new task, and we're just going to call it retrieve activities. And we're going to go ahead and set a parameter of days equals none for future usage of this task. In this task, we're just going to default it to 1 to start. So first, we're going to get all of our user objects, and we're just going to get a query set list of all of our users that have a Strava connection. And that's just going to be basically a giant list of IDs. Then we're going to loop over each of those, and we're going to call our get Strava activities by user and pass it in our user ID equals user, which means we're passing it in the user ID only. And then we're setting our days that we want to do a date range of 1 day. So the reason we're actually calling the delay on this task instead of trying to have everything execute inline is so that we can just queue up all of the execution of this into our queue and then have Celery churn through it at its leisure. The reason that we want to do a queue system for all of these instead of having it run as one huge long task is, let's say we have 2,000 users. Churning through all of these for 2,000 users might take you an hour, hour and a half potentially. But what happens if you want to do a production push in that case, in that time frame? You're going to have to wait for that task to actually end. After an hour and a half, if you have more users, it's going to take even longer. In this case, if you queue everything up, then as soon as you're ready to do a production push, the existing one that's running, once it's finished, it just goes ahead and stops Celery. And then as soon as you do your production push and you start Celery back up, it's just going to pick up where it left off and keep churning through everything as if nothing had happened. So it makes your entire application more resilient. Now that we've created our task, let's go ahead and run it in our shell to make sure it works. First thing we do, if we get our user and then we try to get all the activities for our user, we see we only have 3 activities from when we were doing testing earlier. If we'll go ahead and import our task from activities.tasks, we can then call our function and pass it in the user ID for the user ID keyword argument. If you'll notice, it actually takes a little bit to run, but once it's done, you don't see any errors. So now when we do user.activities.all, you see we have all of the rides that are on Strava. And note there's quite a few there, so that we also didn't do it based on a date range. So as a recap, some of the things you need to think about when you're creating Celery tasks is, what is the bare minimum that it needs to do? In this case, we're wanting to get Strava data by user. This is useful because you can hook it into other tasks to make things more efficient. Or let's say you need to actually, for a single user, get the activity for that specific user. This allows you some granularity when getting data. So it's a good idea to actually try to think through all of the ways you might call your data to kind of do some preparing and preparation and how you're going to do that. And then the other thing is, how can you queue up some of these tasks and run them in such a way that you split them out and have Celery run them in as quick as possible so that you don't have to worry about super long running tasks that might actually eventually fail, or might prevent you from doing other things. So these are some things to think about when you're setting up your tasks and setting up Celery. So with all that said and done, we've taken another step further in creating our product. And in the next video, since Django 1.8 came out, we're actually going to convert our project using Django 1.8 and use the new built-in support for Genja.